Hello and welcome back to the channel. It's been a long time since I last started a new video series, but I wanted to get back to YouTube at this point in history because I encountered a topic that's not only extremely relevant right now, but also it's an excellent introduction to some key scientific topics that I've been covering on this channel so far. And that topic is eco-modernism. Now, you may not have come across this term before, but I imagine you can probably guess roughly what it means. Eco-modernism is a philosophy which encourages the application of modern technology, coupled with rigorous science and logic, to solving the most important ecological and environmental challenges that currently face humankind. It's a modern view of environmentalism, based on investigating the evidence and reviewing whether the routes we've taken so far are necessarily the best ones to get us where we need to be. The eco-modernist believes in using knowledge and technology to help us out of this catastrophic situation, rather than denying the progress we've made as a species and attempting to go back to a primitive way of living that we have sought for so long to escape. Why is this subject so important? There's a vital reason, because we should always follow the data, not our pre-existing beliefs, or the assumptions that we've previously made, even if those assumptions are reinforced in our society and by those around us. So for this presentation, I'm going to go over that principle itself. How should we approach claims that seem to go against our prior beliefs, or the generally accepted cultural answers to well-known questions? Then, in subsequent presentations, I'll actually dive into more detail on some of the specific scientific topics that are relevant to this fascinating and highly important area of study. I'll be looking at how we can protect the environment, how we can deal with the CO2 problem, and how we can move to a sustainable future in balance with our planet. So let's get started. This series of presentations is going to make two major assumptions. Firstly, I will assume that you accept the overwhelming scientific consensus demonstrating beyond any doubt that the human species is currently causing widespread long-term damage to our ecosystem. That this human-caused damage will endanger the survival of many species, including our own, and that it will likely have catastrophic impacts on civilization within the lifetimes of many of us alive today. This shouldn't be controversial, but for some reason, in some circles, it is. Yet, if we look even briefly at the news, the evidence is all around us. We are already creating devastating impacts in many areas, from catastrophic Caribbean hurricanes to widespread devastation caused by record wildfires in California and Australia, to record European heat waves, the melting of Arctic ice, retreating glaciers, widespread flooding, increasing sea levels. The list goes on. If you don't accept the scientific consensus on that, or if you don't even accept that this is the scientific consensus, then this is definitely not the presentation series for you. Sorry. But before you switch over to another presentation, just consider one point. If you would be worried about those things if they were true, then I suggest that it's well worth your effort to investigate the real facts behind those topics, from trustworthy, neutral sources. In fact, I'll put it stronger. In my view, it's a moral requirement to make a careful and unbiased investigation of the claims being made, because if they were true, and of course I believe they are, then they would not only impact your way of life, but the lives of all other humans on this planet. I believe it's imperative we accept what the scientific consensus says on matters where so many lives and livelihoods are at risk, even if it's not what you've been told in the news you listen to, or it's not what your friends and family happen to believe. That's because the scientific consensus is the best information we have about reality, and matching our beliefs and policies to reality is the best way to achieve the outcomes we all desire. But anyway, let's move on. I'm not going to spend any more time attempting to convince people that reality is true. So from now on, I'm assuming you at least all accept the scientific consensus on climate change. However, the second thing that I'll also assume from now on is that you agree that we, as a civilization, should be tackling these issues with top priority, and that therefore it matters that we are highly effective in doing so. What I mean by this is that we need to decide from this point forward that we will look at the data and the science to decide which techniques work best to reduce the damage we're doing to the environment and mitigate the worst effects of global heating. It also means that if we accept that climate change is the number one environmental threat that our society faces, then we should prioritise technologies that make the biggest impact on improving that specific problem. Of course, it's too late to avoid a really bad outcome, but it's not too late to avoid a totally catastrophic one. That may seem bleak, but it's the uncomfortable truth, and after all, that's what this series is all about. And finally, just as a side note, in case you doubt my credentials, because believe me, there will be people who listen to this who think I'm pretending to care about the environment, but I'm just being paid off by some shadowy cabal of big businesses. Here's a little about me. I live in a modest-sized, semi-detached suburban house fitted with solar panels. I travel almost exclusively on public transport, and when I don't, I drive an electric car, which I charge from my solar panels. I get all the rest of my energy from a fully renewable energy supplier who only buys from renewable sources. I have extra loft and wall insulation in my house to make it super efficient, and I collect rainwater to water the garden. I'm mostly vegetarian, I don't eat red meat, I grow a lot of my own fruit and vegetables. I haven't taken a long-haul flight in years, and for what it's worth, my entire house only uses LED light bulbs. And no, I work in technology, and I've never been paid to endorse any of the views I'm going to cover in this series. My job pays well enough, I don't need bribes. In fact, everything I say will be totally based on evidence, not opinion. And I'll give you that evidence so you can check it for yourselves. And if you want to know what I think about the scientific principles behind the proof of climate change, then you need look no further than my presentation on the topic of random walks and climate change at the end of my lecture course on Understanding Science. This video was published on 10th of January 2018, and I'll put the link in the notes below. So, accepting those assumptions, let's continue. One of the greatest psychologists of the 20th and 21st centuries is the Israeli Nobel laureate Daniel Kahneman. Kahneman, together with the late and arguably even greater Amos Tversky, spent decades researching human psychology, and in particular the way our judgments can be affected by biases and by relying on inflexible heuristics. Those of you who watch my presentation on scientific skepticism will know exactly what I'm talking about here. These heuristics are the shortcuts that our brain makes in order to make sense of the world, but which sometimes lead us into error and confusion. In his 2011 global best-selling book, Thinking Fast and Slow, Kahneman elaborated on his theory of System 1 and System 2 thinking. System 1 is what we might term instinct and emotion, the immediate reactions that our brains give us when we are faced with new information. System 1 is the part of our brains that reacts to emotional images. It triggers fight or flight response when attacked, and it runs anything that you can do on autopilot, like riding a bike or perhaps driving a car. System 2, however, is the more conscious, deliberative mode of thought. System 2 takes time and effort and involves processing a wide range of incoming information, knowledge or memories to come to a more calculated conclusion. System 2 is what you use when doing exams, learning to play a musical instrument, performing complex calculations, or weighing up evidence for and against a specific claim. So this presentation series on EcoModernism often sits firmly in System 1 territory. You have no doubt already read and heard a great deal on the ecological crises facing our species, and I'm sure you're fairly well acquainted with the various proposed solutions. Because of the emotions involved in the prospect of existential threat, and the degree to which the consensus among non-scientists is reinforced in our society, it's not surprising that most of our reactions to this topic are fully automatic. But you noticed I said amongst non-scientists back there, and I said that because scientists tend to see the problems a bit differently. So let's look at that next. A major study by Pew Research in 2015 investigated the difference between how scientists connected to the American Association for the Advancement of Science view a number of contentious issues when compared with the general non-expert public. The AAAS consists of a number of active research scientists which make up roughly a third of the membership, plus other individuals who share their vision to advance science, engineering and innovation throughout the world for the benefit of all people. Happily, there was a reasonably large amount of agreement on a number of technological issues. Roughly 2/3 of scientists and US adults agreed that the International Space Station was a good investment for the US. Only 1/3 of the public thought that fracking was a good thing, and scientists were slightly more strongly opposed. For some of the more contentious issues, however, the gap increased. 68% of adults thought childhood vaccines should be required, but 86% of scientists thought the same thing, a gap of 18%. But the gaps increased from there onwards. Only 45% of the public thought more nuclear plants should be built, compared to 65% of scientists. At the time, only half of adults thought global warming was a thing compared to 87% of scientists. Fortunately, both of those numbers have since increased. The fraction of the general public accepting climate change in the US now is more like 60%. Still far too low, but it's a 10% improvement from 2015. And there is now not a single respected scientific body, national or international, that does not accept the scientific consensus on this issue. However, there are still larger gaps between the perception of the public and that of scientists. Some of those were on moral issues, but many were on factual issues. In this case, the gap is not just a difference of opinion, but indicates a lack of knowledge on the part of the public. Some are predictable, like the opinion on laboratory testing on animals. But the largest gap of all, a whopping 51% difference between the opinion of scientists and the public, was around the safety of genetically modified foods. And as I'm sure you've guessed, we'll be talking about those in a later presentation. The results of this Pew survey show that the general public still disagree with the scientific opinion on a number of key issues. And that doesn't mean that they're necessarily wrong. After all, there wasn't a single question in the list that gained unanimous agreement amongst scientists. Though when you further restrict the people you ask to filter out only those who have an expertise in a specific subject, then the numbers do change drastically and the gap is often even larger. Only 87% of scientists in the 2015 survey accepted climate change, but the number of climate scientists who do so is above 98%, and no prizes for guessing which industry funds the remaining 2%. This teaches us a valuable lesson. Being a scientist in one discipline doesn't mean you have expertise in all scientific disciplines. For pretty much any claim, no matter how certain it is, you can always find at least one scientist who is willing to go on record saying it's false. For various reasons. Sometimes because they're paid to do so, sometimes because they genuinely believe it. There are Nobel laureates who think that psychic powers are real, for example. So be wary of anyone who says, this must be real because a scientist said it. Instead, make sure, as we've done in this presentation, that you look for the consensus of relevant experts. This 2015 Pew study tells us something. It tells us that once you start looking at the world in a scientific way, and once you start researching the available evidence and go out searching for more evidence of your own, your opinions on a number of important topics are likely to change. This is completely expected, of course. It would be very strange indeed if that were not the case. After all, if spending years or decades thinking about an issue, discussing it with the smartest minds in the field, and conducting painstakingly detailed evidence-based research didn't ever change your mind, that would be rather surprising, to say the least. But that should at least raise a red flag for you, that some of the things that the general public agrees on in good faith are not actually correct. And I don't doubt the good faith of the general public here. It's possible to really and truly want to change a situation for the better, but to pick a misguided way of doing so and have a less effective impact than you could, or, even worse, to actually make the problem worse. Think of those parents with sick children who desperately want to help their precious child get better, but fall foul of some convincing-sounding charlatan who feeds them an ancient herbal remedy that not only doesn't cure any illness, but might actually make the child worse. Sadly, it's an everyday occurrence. So what I think we need to agree on here is that there are some topics that are highly emotional, and when those topics arise, we generally tend to have a reflexive opinion about them which is very difficult to shift. This System 1 thinking that I introduced a few slides ago isn't going to help us to get to the bottom of what is really true. And what is really true is what we need to discover, because that will empower us to solve the actual problems that we face as quickly, cleanly and safely as possible. But there's another question that we need to answer, the good old faithful trope of open minds. A favourite insult of those favouring pseudo-scientific claims like psychic powers or ghosts is that people who don't accept those same fringe beliefs are closed-minded. We need to have a better definition of this term, I suspect. To me, the only sensible way in which we can define open-minded, such that it remains a virtue, is that any person should be willing to accept any claim, so long as that claim is backed up with a sufficient amount of sufficiently good evidence, and reject any claim when faced with a similar balance of evidence against. Acceptance and rejection are provisional, of course, and can be overturned when that balance of evidence shifts, but only then. What open-minded cannot mean is that you accept anything you're told. That's not being open-minded, it's being gullible. So we need to cultivate a habit of open-mindedness. This means that no ideas are off limits, but also that no ideas are true beyond question. Absolutely everything can and should be questioned, but conversely you should agree to accept any claim, no matter what your initial reaction to it might be, given sufficient evidence in its favour. I hope this presentation has served as a rather unusual but necessary introduction to the topic of eco-modernism. And it's done that not by actually introducing the topics I'm going to cover over the rest of this course, but rather by looking at the much higher level question of how we should approach unfamiliar claims. If you made it this far through the lecture, then you're one of two kinds of people. You're either someone who cares about the environment and wants to get down to the details, and you're not really sure why I apparently wasted an entire lecture talking through general principles of scientific skepticism. Or you're someone who cares about the environment and already agrees with everything I'm about to say in the rest of this course and fully understands why I had to do this lecture first. Either way, the good news is that I'm pretty sure that if you got this far that you do care about the environment. And let's face it, most people do. The reality of global climate change cannot be denied by any intelligent human being who has honestly reviewed the evidence. But there is still a lot of debate about how to tackle it. Some of that debate is fully valid and some isn't, but at least we all agree that we need to get from point A to point B. The task now is arguing over which route to take. This presentation series will talk about a number of emotive topics, from nuclear power and genetic modification to organic foods, meat eating and vegetarianism, renewable power, carbon taxation, electric vehicles and recycling. We'll take a closer look at the timescales involved and the realistic outcomes. My aim is to challenge you, to educate you and to help you decide whether you want to be an active part of the solution. I very much hope I succeed. Thanks very much for listening. I hope you continue to listen and join me on this exploration of an extremely important topic. See you next time when we'll start looking at the first topic in this series, where I'll investigate the claim that nature and technology are enemies and that natural always equals good.